video on center of gravity and centroids. Essentially, what we're going to do is just figuring out how to find the center of gravity of something, an object. In our case, it will be 2D objects. Finding out what the centroid of objects are as well, and these are going to be like weird objects, not like a square. What's the center of a square? Well, we all can figure that one out. Or what's the center of a circle? So we're going to start figuring out what's the center of a semicircle. That's a little bit harder to do. So let's start with some of these formulas right here. So center of gravity is the point at which the entire weight of the body may be considered as concentrated so that it can be supported at the point. The body would remain in equilibrium in any position. So center of gravity of a lamina. So what this is stating here is if we have a lamina, that's like a density. But luckily what we're dealing with is homogeneous lamina, where it's not going to change, not a functional lamina. So what's going to end up happening here is if you look at these equations, this little guy right there, that's a lamina. Okay. These are going to end up canceling out because these are going to be constants. Okay. So since those end up canceling out, you're actually going to end up with something down here. So if you have a homogeneous lamina, which we are going to have, then you're going to end up with this formula down here. So it's 1 over the area of R x times f of x. And this is going to get you the center for x. And then the center for y is right here. So that's what we're working on. So if you see any questions that have a density of a number, it means it's homogeneous and it doesn't matter. It's not going to change how we do things. So this first example right here, find the center of gravity of a triangular lamina with vertices. So what I'm going to do here is I'm going to go ahead and sketch this so we know what we're dealing with. We have vertices 0, 1, 0, 0, and then 1, 0. So they're all here. So I want to find out what my center of gravity is for this. It has a density of 3, and that's actually going to be useless. So we don't care about that, again, because in my formula, I'm going to type in a 3 there and a 3 there, and it's just going to cancel out. So I'm not even worrying about that. So what we need to do is we need to find the area of this, and then we need to start plugging it into these formulas down here. So for the area of R, that's not hard to find. Okay, so this area right here is going to be, well, it's a triangle of, so it's 1/2 base times height, because it's a triangle. Base is 1, height is 1. So this is going to be 1/2 times 1 times 1, which is, well, 1/2. Okay, so to find the x center, we're going to do 1 over the area of R, which is 1/2. And we're going to integrate. This is all dx's, so we're going to go from left to right. So it's going to go from 0 to 1 of x times f of x. Now here's the, not tricky, but here's the work we got to put in. What's f of x? Well, let's look at our function here. We're integrating from here to here, right? So we're integrating from this function to 0. So what is this function? Well, this is a line with a slope of -1. So it's y equals -x plus 1. So that's our function. So -x plus 1 dx. And you will have a calculator in your hand. You don't need to worry about anything else. So when you do this, let me just look at my, it's okay here. You're going to end up with a third. Literally just type that in the calculator. You're going to get a third. For the average y, 1 over r. Again, I'm using this formula right down here. So 1 over r. And we're going to integrate from 0 to 1 of 1/2 the function squared. So I'm just using these formulas. You type that in the calculator. Oh, look at that. You end up with 1/3. So in this triangle, I'll go ahead and use my little pink pen here. The center of gravity here, or centroid, is about right there. 1/3, 1/3. About where my pink is. Okay. Which makes sense. If you do your center of gravity and it's like way out there, something went wrong. So I like to usually sketch it and graph it and make sure that we are good to go here. Okay. So that's all it is. It's just using these formulas. Find the area, find the function, and let's go. That's it. All right, so let's find the centroid of the semicircular region from -a to a. Okay, well, that's kind of annoying. So let's go ahead and find the region R first off, the area of R. This is a semicircle, so it's 1/2 pi r squared. And our radius is a. So in our case, we're going to get 1/2 pi a squared. Okay. So when I'm finding x, I'm actually going to go think a little bit outside the box here. What's my average x value of this function? What's my average x value? It is symmetric on the left side from the y-axis on the right side. Since this is symmetric, I can just look at this and go, well, my centroid won't be here. It won't be here. It'll be somewhere on this line right here. So because it's symmetric, ignore the calculus. Your average x value is 0. Okay. Oh, real quick. Go back to the first one. I think I ever answered my question here. Center of gravity is 1/3, 1/3. I didn't actually write that out. Sorry. I'm trying to make this video not so long. Now let's go ahead and do the y. The y one, unfortunately, it's not symmetrical, so I'm going to have to go through and find out what this is. So it's going to be 1 over my area, which is 1/2 pi a squared. And I'm going to be integrating from negative a to a of 1/2 my function. Now, what the heck is my function? I can find that out here. Let's go ahead and do that. What's my function? Well, this is a semicircle centered at 0, so usually it would be x squared plus y squared equals, in this case, a squared. So I'm going to solve for y here, so I'm going to get y squared equals a squared minus x squared. I'm going to square root it. Now, usually I do plus and minus. Plus is top, minus is bottom, but it's a semicircle, so I don't do the plus and minus because I just care about the plus. It's going to be a squared minus x squared. So that's my function, not plus and minus because it's not a whole circle. So I'm going to get this a squared minus x squared squared dx. Okay. So a couple things that nicely happen here. I'm just trying to see what shortcuts I can pull off. A couple things that nicely happen here is this square is going to knock out that square root. So that's going to go away. And then this 1/2, when I pull it out here, is actually going to get rid of that little 1/2 in the denominator. So I'm left with 1 over pi a squared, negative a to a of a squared minus x squared dx. So this one I can't use my calculator because I'm using bounds of a. So I'm going to kind of go through the integration here pretty quickly. So when I integrate, here's the outside. I'm just going to leave it alone. The antiderivative of a squared with respect to x. A squared is a constant, so it's just going to be x times a squared. Minus antiderivative of x squared is 1/3 x cubed, and we're evaluating that from negative a to a. I'm going to kind of save you the math here. So that's really the big part. I'm going to plug everything in. We're actually going to end up getting an answer here of 4a over 3 pi. So my centroid here is, well, I found the x1 pretty quickly. That's not a big deal. And then for the y1, I'm going to get 4a over 3 pi. So again, all you have to do is just plug in these a's. I'm just trying to save you some time. Okay, so what is this estimate to be about? Well, pi is about like 3-ish, so it's going to be like 4 over 9 times, so it's like 4/9 of a, which is almost halfway, so it's a little bit lower than half, so it makes sense to me. All right, now that we have these formulas down pat, I'll probably go through some of these a little bit quickly here. So find the centroid of the region. So you notice we're ignoring the lamina because, again, it's not that important for us because the lamina is homogeneous, so we're just focusing on centroids here. It's the centroid of the region R enclosed by the curves in there right here. So now I don't have just basic shapes that I can just find the area of, like semicircle or like a triangle. So to find r, you're actually going to have to integrate. So you're going to have to integrate, find out the area between these two functions. So let me sketch these two functions real quick. So x plus 6 is like up here. Okay. And then y equals x squared is this guy right here. So I'm trying to find the centroid of this, which I'm guessing, if I was a guessing person, it's like somewhere in here-ish. Somewhere in there. So to find r, I have to integrate. I'm going to do top minus bottom. Okay? So I'm going to integrate. Now, first off, I have to find out where these intersect. So I'm going to do x squared equals x plus 6. See where these intersect at. I'm going to get x squared minus x minus 6 equals 0. This will factor. Minus 3 plus 2. So I'm going to get x to equal negative 2 and 3. So I'm going to integrate from negative 2 to 3. My top function is that linear function, so it's going to be x plus 6 minus x squared dx. Again, I'm putting the calculator in your hand. Just type it in. You can do this by hand if you really want to, but you're going to get the r here to be, oh, that's a fun number, 125 over 6. Okay. So to find x bar, it's 1 over r. We're integrating. We already found those bounds from negative 2 to 3 of x times the function. Okay. This is the function right here. This function, f of x, is equal to x plus 3 minus x squared. Okay. So x plus 6 minus x squared dx. So you just set it up. Type in the calculator. You get a clean 1/2. So for y bar, same thing. But now it's going to be my function squared. So, well, it's 1/2 my function squared. So it's 1/2 of my function squared, which is x plus 6 minus x squared, all squared. Calculator. Wow, what a clean answer this was. This is 4. So my centroid here is 1/2 comma 4, which if I go up to my picture here, pretty good. Pretty good. Last question here. Find the centroid of the region R enclosed by the curves. Oh, I'm missing this. I was like, whoa, it's an infinite one. That's not going to happen. Sorry, this is missing information here. Let me make sure I put it on the notes. What's this? So it's between the curves, y equal root x, y equals 1, y equals 2. Okay. So let's go ahead and sketch this. So at 1 and at 2, what's the square root of x at that point? I think it's going to be right here at 1, and then this is all the way out here. So this is the figure that I'm sketching. So I need to find the centroid of this figure. Now we're doing everything in terms of y, which is actually fine because when I do my integration, I want to do it in terms of y. Because if I go from right to left, it's easier than going up to down. Right, something that we learned throughout the year. So if you can do right to left, we will. So for r, is going to be equal to the integral. So we're going to go from 1 to 2. And this is all in terms of dy because it's easier to go from right to left. So it's the further right function. It's going to be, well, what is that really? Isn't that the same thing as x equals y squared? It needs to be in terms of x. So it's going to be x equals y squared. This is going to be y squared minus 0. I don't need that minus 0. So it's y squared dy, which is 7/3. Now here's the kicker. This is why we're doing this problem. is if you look at these formulas up here, they're all in dx. Okay. If you do dy, you need to flip the formulas. So since we're doing dy, since we are doing dy, we flip the formulas. Okay. So for x bar, instead of it being this one right up here with x's, it's actually going to be this one down here for y's. Okay, so it's going to be still 1 over r, which is 7/3, integrating from 1 to 2 of 1/2 f of y, f of y all squared. So what is f of y? That is just y squared. So again, we are flipping them. And then what do I get here? Oh man, that's a fun one. 90 over 73. Wait, no, I'm dyslexic. 93 over 70. It's 93 over 70. And then so y bar is flipped. So it's going to be similar to x bar, but instead of being x f of x, it's y f of y. So it's y f of y dy. Which, just type that in the calculator, I'm going to get 45 over 28. So my final answer here is 93 over 70, 45 over 28. All right, so that's like a little bit, these are both a little bit over 1. This one's a little bit bigger than 1, the x value-wise, and then this one is closer to like 1.5, I would say. So for my centroid, so this is my picture right here, a little bit bigger than 1, about 1.5-ish. So up there. This is not the scale, so maybe if it was the scale, it would look better, but because I think this out here is 4, right? 1, 2, 3, 4. It's not the scale. So deal with it. All right, and that's going to wrap it up for centroids. Again, I'm not looking for you to do the actual calculus in there. I'm looking for you to set up the calculus, and then you can just go ahead and use your calculator to solve.